Okay, let's continue this one. F is strictly, this is graphs of functions, video number 10. And we found in the previous video that the derivative is strictly positive, then the F is strictly increasing function. All right, this we studied the behavior. Also, we should study the behavior of F double prime of X. What is F double prime of X? It's U prime, it's the derivative of the derivative. It's the derivative of 5 over, right? Of 5 over 2x minus 1 squared. It will be a derivative of 5, 0 into 2x minus 1 squared minus derivative of 2x minus 1 squared will be 2 times the derivative of 2x minus 1 times the 2 times 2x minus 1 times the derivative of 2x minus 1, which is 2 over 2x minus 1 to the power 4. Then it is equal to minus 4 into 2x minus 1 over 2x minus 1 to the power 4. We can simplify one of the 2x minus 1 here, 2x minus 1 with one of the 2x minus 1 down, it will be 1 minus 2x to the power 3. Alright, this is negative, we know, so it depends on the sign of this. If, because it's a cube, it's not positive value. Okay, if 2x minus 1 is positive, right, then in this case x will be greater than half. In this case, x greater than half, this is positive, the numerator is negative, so the whole derivative, the whole second derivative will be negative and concavity will be downwards. And if it is negative, x will be less than half and the concavity will be negative over negative positive, so concavity upwards. Let's see if we can find particular points. It's x minus 3 over to x minus 1. Okay, we cross product, so we do we don't cross product. I thought I'm finding the inverse. So we do what? We if, let's say, if y equals 0, this means x minus 3 over to x minus 1 will be equal to 0. And in this case, only the numerator will be equal to 0. This means x will be equal to 3. So we have particular point 3, 0. And if x equals 0, that gives me that y equals 0 minus 3 over 0 minus 1 minus 1. So it's equal to 3. So we have another particular point which is 0, 3. Now let's draw. To draw, we have to go back to the beginning, right? Because there's very important thing, we kept it for this thing. Sorry, from the beginning of this problem. So it's here, right? What do we have here? We have y equal half is a horizontal asymptote. This is very important thing. And x equal half also is a vertical asymptote. So we have two asymptotes at halves, x and y. So let me directly check how to draw it. It's simple, not in red. Okay, the y-axis. Okay, never mind. And the x-axis, right? Let me just try to change. Okay, no problem. So y-axis and x-axis. At x, this is 1, this is half, this is 1, and this is half. At x equal 1, we have horizontal asymptote. Let's draw the horizontal asymptote in red instead of dotting it, right? Horizontal asymptote, let's draw it in red. It's not horizontal, sorry, it's x equal half, vertical asymptote. And this is at x equal half. And at y equal half also we have asymptote, and it will be for sure a horizontal asymptote. Okay, this is horizontal asymptote. Okay, what else? Let's put the particular points, they are important. 3, 0, 0, 3, right? We got 0, 3, we got 3, 0. 1, 2, 3, This is half, this is 1, so this is 2, this is 3, 0, and this is 1, this is 2, right? This is 3, so this is 0, 3. Okay, this is half, this is half, this is 3, and this is 3. All right. What do we have here? Let's check the table of variation, right? It's important to have table of variation in front of us. We didn't do table of variation yet. Well, that's nice. I forgot to do the table of variation. It's good. So we can do it here beside us because we need it to be beside what we're working. It will not work. Line in hand is hard. X from minus infinity to plus infinity, and we don't have half, if you remember. At half we have horizontal, we have vertical asymptote, right? And this is the derivative. As I can remember, we got the derivative is strictly positive value. This is the second derivative, right? Let's see. We found it as from if x greater than, you remember if we did this, if x greater than half, then concavity downwards. If x less than half, then concavity upwards. If it is greater than half, concavity downwards. If it is less than half, concavity upwards. So we now can do the half of x. Half of x, it's increasing. Concavity here is upwards, and concavity here is downwards. We don't have any special point here because the function has asymptote, right? And as x tends to minus infinity and plus infinity, we got half as horizontal asymptote. So it goes from half to plus infinity, then from minus infinity to half. Now it's from half asymptote. Now I'm going to draw from half asymptote, horizontal asymptote, to half minus, passing through this point 0, 3. So it goes from like this, and concavity is upwards, as you can see. It's asymptote, it cannot touch it. And from minus infinity to, in the red asymptote, vertical, to half, goes all the way, it cuts, it's like that. And that's it. This is the drawing.